We are back with another Sudoku and some dinner. Today we have Raining Cats and Dogs by Billy Beth, and I will also be raining some dogs into my mouth during this video. If you like Sudoku or puzzles, I'm dropping one of these every day, so drop a like and a follow. There's a lot of rules. So the red lines are the cat and the dog. The sum of the digits on the line is equal to the sum of the digits at the circles. These two circles are going to equal all of these total. And this is 8 cells are going to equal 2 cells. This is also 8 cells is going to equal 2 cells. So what's the minimum value of 8 cells with these constraints? We can do 1 and 2 all the way around, which would give us, oh, this one has to be 1, 2, 3, 4, which is 10 plus 3 plus 3, 16 for this one. So that's, this one's going to be pretty similar. This one is 1, 2, 3, 4. This one is 1, 2, 3. These are 1 through 4, that's 10. If these are 1 through 3, that's 16. And then this one makes it 17. So this is 8 and 9. That's like the most limited option, I think, right? Quadruple circle. The 4 cells joined by the quadruple circle must between them contain any numbers in the circle. So yeah, it's telling us there's a 1 here, which we just knew from this constraint. Got a little bit of a duplicative constraint there. The rest of this box is 5 through 9. Which is a bad pencil mark, but this, I want to see what this yellow line is. Digits on a yellow line cannot be consecutive with any other digit on that line. That's perfect. So this tells us this cannot be 6 and 8. We can't do like 6, 7, 9, or because 6 and 7 are continuous, or not continuous. Consecutive, I guess is a better word. So 6 and 8 are not here. These are 1, 2, 3, 4. They can't be 4 because 5's on it. So we have 1, 2, 3 triple in the column. Now these are bands. No, these are not normal rules. Purple lines must be consecutive, but in any order. We'll see how that goes. And then the green lines are German whispers must differ by at least 5. So we'll figure that out in a minute. This is telling us there's a difference of 3 in these cells. Maybe that'll come in handy later. If one of these is 1, one of these is 1, one of these is 1, then there's a 1 down here. There being a 1 down here, well, we could have known this before. This can never be 2 because 2 is consecutive with both 1 and 3. So this is going to be a 1, 3, 5, 7, 9. This is not 3, so this is 2. These can't be 2. There's a 6 up here. There's an 8 down here. This is a 6, 4. This is a 5, 7, because 8 and 9 are here. 1 and 3 are here. 4 and 6 are here. This having a difference of 3. We have 1, so this might restrict the cat, assuming this is the cat and this is the dog. This is going to restrict this because if we do 1 through 4, and then we put 5, this, which is the minimum. And then this is going to be 5 and 8, or 5 and 9. 7 can't go here. So if 7 can't go here, then it's got to be 8 or 9, right? So it's a 5, 8, 9, or a 6, 9, I guess, maybe. And then 7 has to go here because if we don't put 8 and 9 here, then we can't do this 3. There's always a 7 here. It can't be 7 and 8 because we said this was 16, right? 1, 2, 3, 4 is 10, 13, 16. So yeah, this is 7 and 9. So it can't be 6. So it's 5, 8. These can't be 5 or 8, and then we know these are 1 through 4. These are 1 and 2, and these are 1 and 2, which tells us this is 3, this is 1. We have a 1, 2, 3, 4 triple here, and we have a 7, 9 pair, so this is 5. These are the other high digits, 6 and 8. These are the other low digits, and then these are all high digits as well. I should probably just color this puzzle high-low. This is a 6. It is orange, but I was on color mode on accident. These are all high. 7, 8, 9, or 6, 7, 9. No, there's a 5 up here. They're not all high. 5 can't go on green lines. Is it? Oh, wait. Did I mess up? I messed up. Uh-oh. Where's 8 in this? There's an 8 down here. This is 7 or 9. What am I missing? No, 6 and 8 are here. Oh, 6 and 8 are here. So what are these can't be 8. There's always a 9 here. Let's rethink this. This 1, 5, 7, 9 thing is locked. So this is always 6, 8. Hang on. Can we put 5 here and then put 4 on this and do 4 and 7? Say we did 8 and 9 here. That's 17. We can switch 4 out with 5. Yep. Oh, that's what it is. So 4 can go here. That's what I was missing. How do I prove that? Because why can't it be 5 and... this can still be 7, technically. Why can't this be 5? This can't be 8 because of 6 and 8 are already in the row. So why can't this be 5 and 9? Because 7 and 8 is too small. So 9 is always here. 9 is never here. So now the only high digit left is 7. So it's 4 and 7. And 5 has to go in here now. That was a terrible fumble, but we're back. We're back to a normal puzzle. These have to be consecutive, so this can never have a 9 on it because 8 and 9 would break. So this can never be 8 and 9. That makes sense? Can I figure this out? That's the question. 1, 2, 3, 5 is now, it has to be 8 and 9 now. This can't be 7, but we knew that from 4 and 7. And not 9, so 1 on one of these. Can't be the pink one because they have to be consecutive, so this would be 1 and 2, and that breaks this. This is a 1, so there's a 1 up here somewhere. 5 hot dogs in 21 minutes while barely starting this puzzle is not bad. If you made it this far in the video, smash the follow and like button. That was a new one for me. Can't be 1, 2. It can't be 4, 7. It can't be 6, 8. 3, 5, 9. So this is a 3, 5, 9 triple. So this can't be 3 or 5. So this is a 1, 2 pair. 6 here. 6 on the green line can only pair with a 1. So this cannot be 6 because then 1 cannot go above it. This is 6. This can't be 1 or 2 or 3. It's a 4, 5 single. Not single, I guess, but it can't be 5 on the green line. So this is always 4 and this is always 9 by the green line logic. This can't be 9. 5, 7 pair. This is 9, which makes one of these 9, which we knew. One of these is, this is the only place 7 can go now. 7, 5, which makes not 5, which makes this 5, which makes these not 4, which puts a 4 here. So these are 1, 2, 3, 4 triple now. So this is 8 and 7. This can only be 3 by being 1, 2, and 4. These can't be 9 anymore. 5 can't go on the green line, so we're looking at 5 and 3. This is now an 8, 9. 5, this has to be consecutive with 5, so it's a 4, 6. Can't be 4, so it's 6. This has to be 7 or 8. Can't be 6 or 9. This one is now a 7, 8, or 2. 8 and 9 in this box can go with 2, and 9 can go with 4. But 1 and 3 are Sudoku'd. Consecutive from 6 or 8. So we could do 5, we could do 7, we could do 9. We could also do 8 because this could be 6, this could be 7, this could be 8. Oh no, 8's in the box. 8's in the box. So none of these can contain 8 in this box. Oh, 1 and 2 are in the column vertically already, so 3, 4, 8, 9. This one can't be 8. Where's 5? 5 is in one of these. 7 or 8 can get as low as 5, right? So we could do 5, 6, 7, 8, 9. And there's no, oh, the 8, 9 are Sudoku'd out. And then this one can be also 5, 6, 7, 8, 9, and there's no Sudoku to limit what we can do here. 2 down here. 2 here. So there's a 2 here in this row. What's a 2 here? Which puts nothing here. This row is 4, 5, 6, 7. This one can't be anything 5, 6, or 7 because it's next to 6 and that's yellow line, so they can't be consecutive. So this is always 4. Now our options on this are 1, 2, 8, 9. We can't be next to 4 or 6, so we can't be 3, 5, or 7. 5, 6, and 7 on pink means we have to go up because 4 is here. So we have to do 5, 6, 7, 8 because one of them is going to be 5, 6 and one of them is going to be 7, 8. And 5 can't go on the green line, so 5 is always on the bottom. So the 5, 6 is on the bottom. So this is never 6. This is never 7. These are never 8. So we have a 6, 8 in the row, which gives us this 4 and this 6. And then we get, this is a 6 as well, which tells us this can never be 9. One of these is 5, one of these is 6. The 1 goes with that, so this is a 2, 9 pair. The 1 has to go with 6 on the green line. If that makes sense? So these are never 2 either, so the 3 goes with the 8. 1, 2, 3 in the column now, in both columns. So the 3 in this box is down here. If it went on this, this could be an 8, 9, that's fine. What is this? Oh, 1, 2, this is now a 1. Okay, we're gonna unravel all of this because of this 2, 9, so this can't be 2. So this is 1. These can't be 1, so this is a 2, 3. Means these are not 2, which means these are not 1. Means this is 1, this is 2. Didn't go as far as I hoped it would. We don't need these pencil marks anymore. Those ones are still kind of helpful. What are these numbers? 3, 8, 7. This one can't be 3, and 3 can't go with 8. Okay, this is an 8, 3, and this is a 7. And then that will solve some other stuff probably. This is a 9. This can't be 9. This can't be 9. This is a 5 now because it can't be. These can't be 9. This is a 4, 5, 7 as well. 4, 5, 7, 9. No, none of these are 9 actually. This one's on the bottom. 3. This has to be 3 and 8 also. This is a 7. This is a 7. This is a 5. 5, 6, 7, 8. 4, 5, 7, 2, 8, 4, 9, 2, 9. This got us where we needed to go. Took a while. These last 2 columns are just empty. And we're going to need to use the green lines again, I imagine. This can only be 4 and 9 now. We can't place that yet, but these are 5 and 6. We can place those, 5 and 6, which tells us 8 and 7 go here, and 5 and 6 go here, which means 3 and 1. Down here we get 9 and 8, and 2 and 3, and 7 and 4, and 1 and 2. So this can be 2, 9, or 4, 9, so this is never 6. Then we have a 4, 9 pair in the row, so this is 6. A 2 down here somewhere. 6 gets us something. 6, 8, 7, 6, 7, or 6, 5, 4. That's what it is. 9, 2, 3, 2, 1, 4, 9, 8, 3, 1, 5, 7, 9, and 4. Wow. It took me 21 minutes to eat the hot dogs, and then it took me another 18 minutes to actually finish the puzzle. If you like the hot dogs and the puzzle as much as I did, you can drop a follow because I'm posting one of these every day.